All right. So I'm going to share my screen. Okay, can we see my screen?
Yes, yes.
Okay. Um, as I said before, the topic for today is model selection and evaluation. So these are the learning objectives. Okay. Um, please, can you give me a second? I'm coming. Sorry about that. Okay, so the learning objectives for today is to understand why we evaluate and select models. Is everybody right on track with me?
Yeah, but your screen, okay, it's back now. It's
It's
back
back.
now.
Okay, is it
Yes.
clear?
Yes, it is.
Okay. So by the end of the session, our mothers, our students will be able to understand why we select and evaluate models, know what confusion matrix is all about and how to interpret it, understand evaluation metrics, which are precision, recall, F1 score, and when each of them matter. Then know what MAE and MSE measure. That is mean absolute error and mean squared error. For the former class, I saw that you guys you worked on it, so I don't know how much you know about it, but I'll just give a brief definition or explanation about it. So at the end of it, we should be able to compute all of this in Python using sklearn, and we'll practice on a real data set. Are we good? Are we good?
Interesting.
Can you hear
Good.
me?
Yes, we
Yes, we
can.
can hear
So
you.
we
Okay.
use reactions also so that we don't all keep talking. That's
Okay,
okay.
okay, okay, okay. Okay, so moving on, model selection refers to the process of choosing the best machine learning model for your specific problem and data sets based on how well different models perform. So, for example, imagine you're trying to make the perfect recipe for your birthday cake and you try out vanilla flavor, carrot, red velvet after tasting each one. Then choose the one you want specifically. Maybe for that birthday, your daughter wants prefers red velvet or carrots, but she has never tried it. And then you try different recipes, and then when she tastes it, and she's like, "Oh, that is the best recipe. That is the best flavor." Sorry. So that is what model selection is all about. So why do we need to select models? As machine learning enthusiasts or data scientists, this is a very critical requirement to select models, to know how to select models. So, first thing, different problems require different solutions and approach in machine learning, in data science in general. So, a model can work for one data set and it might not work for the other one. That is very practical. Some models can be simple, some models can be very complex. And now we are looking at when we are looking at simplicity and complexity, we are looking at the features of the model, we are looking at what we are expecting from the model. So now how do we select models? Um before I move on, I want to apologize for the font in case it's not really clear or it's not really large. I had to pull this up on a short notice. So please bear with me. The model selection, how do we do it? So when we are doing model selection, we have to sit down and define our problem and the expected results we need from our model. So these are some factors, the main factors we need to consider. And we check if it fits the data well, that particular model, if it fits the data well. So a good model has high accuracy, low error. Then a good model should be able to generalize to new unseen data. So when you train a model, now I want to train a model to predict rainfall in a particular area, and I use a data set of over 25 years. So let's the 25 years now has been like from maybe 1981, and now we're in 2025, right? A good model should be able to predict on unseen data of what 2025 could probably bring, like the changes in the climate of 2025. So that's why you have to tweak the features, look at the accuracy, the error. So that model that was trained on the 1981 data sets, if it is a good model with proper correction, proper accuracy, proper evaluation metrics, proper addition of features, and you update the data sets at a particular time, you should be able to predict the climate change of what will happen in 2025. So another factor is a good model should also meet the need of the task in cases of speed, interpreting the problem. So there are various factors. A good model, let me think of another one. A good model should also be fast. Okay, that's already in speed. A good model should also be simple. As machine learning or data scientists, you will notice over time, even with the complex models, we try to fine tune. There's something called fine tuning it to make it simpler. So it's just based on the volume of data, based on the task, based on the variables, target variables you're trying to get. So, are we understanding what I'm saying? Are we
Yes.
in touch? Okay. Okay. So moving on. So considerations for selecting a good model. So like I said earlier, the type of the target variable. As we know, we have two main types of models in machine learning. That is the classification and the regression. The classification handles categorical data. What it does is it predicts based on category or class. Regression now, it predicts based on continuous variables. So now when I'm trying to, get the house price of a particular estate over years, we have a data set. Oh, this land has this price, this particular land has this price. So to predict what the third plot of land would have, that is regression model. That's I'm trying to simplify it. I hope you understand regression model very well because it's also core. So size of data too is also a consideration for selecting a model. There are some models that can work with particular sizes of data. What I mean by that is some models will train very well on little amount of data, while some models will train very well on large amounts of data. Now, the little amount of data, they can be very simple, maybe 6 features. That is, if you are very familiar with pandas, these 6 features, when you turn it to the number of columns, well, if you have a particular data set, you update every year. let me say the people that come to buy a particular product on AliExpress, that's a good one. You have various columns. You can't use a simple model for that. You have to use a complex model to predict on when next a customer can come and buy that particular product. So another thing for selecting a model is time and resources. You don't want a model that would waste your time, and you don't want a model that would waste your resources. While there are some cases that models would waste your time, and in the terms of resources, there are some models that can't run on every normal system. There are some models that need what we call GPU. Our system, most of our systems, we have CPU. So don't let me confuse you. What I'm trying to say is that these models will need large computing speed. So that is another thing we are looking at. So class imbalance or balance. So I have a data set, 500 customers, and each columns we have the features female, male, that's for the sex. Then we have the age, maybe we have the height, we have the weight. So when some particular fields in the data set, some particular descriptions in data sets for some customers are missing, this is going to be a class imbalance. Now let me go back again. So I said we have the sex, we have the height, we have the weight, age. So in each column, and I said 500 customers. So if the age column has 400 values and the remaining columns have 500 values, that's already a class imbalance. So there are certain models that can handle that, and there are certain models that can't work with that at all. So that is another consideration when selecting a model. So I would have, maybe I can draw up resources for us to look at in cases of class imbalance, because most of the data sets we have is always balanced in the sense of if a missing value or missing value in a column or missing value in a class, we always fill it up, right? We always fill it up with dummy data. That's what they call it. They call it dummy data. So things like models like linear regression to avoid errors, those class imbalance, we fill it up with dummy data. Are we good?
Yes, please.
Okay. Thank you very much for your attention. So moving on, the model selection factor. I have briefed through that. So understanding your problem, a problem well understood and drafted in selecting machine learning model is 50% of the model development. That is already half work done. You need to understand your problem. You need to understand if it is a classification or regression problem. You need to understand if your data sets, your target variable, if it's training on particular classes, what you want to get. Maybe I want to predict the sex of of the particular customers. So I'm looking at the height, I'm looking at the age, and I'm looking at the weight. So those are the things we also look at. So you have to understand your features, the features you are using to predict. You have to be clear about it. So after model selection, what comes next? So just like when we are trying to make particular suits or we're picking the best material for cloth design, we've looked through maybe it is cotton, silk. The next thing is to tailor the clothes. The next thing is to make the suit. So after the model selection, we train our model. So I've gone through the formal codes of the last class, and I saw you were familiar with train test splits, one of the popular methods of training our models. where it we specifically puts the amount of data sets we want to train, the amount of data sets we want to test, and that's it. So we also have validation, but we can always, I will go back to that when we are at the code area. So moving on. Hope I'm not so fast.
No.
Okay, thank you very much. So moving on, model evaluation. We spoke about model selection. So now that we've selected our model based on our problem, based on our features, based on our target variable, we know what we're expecting. We've built our model, we've trained it. How do we know our model is performing very well? Now, this is very important because you can build a model and you think you are done with the model because it will show high accuracy. But as much as you see high accuracy, you check the error. So, like I said earlier about the data set of the 1981 to 2025, that was about generalizing to unseen data, generalizing to new data. We evaluate our models to see if it can actually generalize to unseen data. We evaluate our models to see what is lacking in that model. We evaluate our models to see how good is the performance of our model. So after training a model, we need to measure how good it is. That is basically model evaluation at its bare surface. So metrics depend on the type of problem. When I mean metrics, evaluation metrics. Metrics in general sense means measurements. When you see metrics in things like engineering or things like geology or weather measurements and you hear metrics, it's all about measuring how wide, how good. So there are different factors for measuring. So now the main, the two main models we are working with in machine learning, two main classes of models. That is the classification and regression. The metrics that are used in classification include accuracy, precision, recall, F1. The F1 is also called F1 score, and also confusion matrix. Confusion matrix can be visualized, and precision recall and F1 using sklearn can be put as a report. So for regression, we have mean absolute error, mean squared error, root mean squared error. I know we are probably familiar with mean absolute error, mean squared error, root mean squared error. Time won't permit me to really discuss root mean squared error, but moving on. At first, when we build a model, we are looking at how accurate it is. That is, I'm trying to predict the rainfall in a particular area, and I've built my model, I've trained it, and then I saw that it's giving me a good response. But don't just stop at the good response. It's probably giving me a good response that is, oh, it is going to fall in this area maybe next tomorrow, and the weather for the weather for tomorrow says, oh, it's going to fall in this area next tomorrow. That is a good response. Does not necessarily mean your model is correct. If you put in unseen data or a new data, it might not be able to give good responses again. That is one thing we need to consider. So how do we solve this problem? Things like F1 score, precision, recall, they are deep rooted into statistics and calculations. But to simplify it, we have modules in Python using scikit-learn, that's SK-learn. So The three main ones we are going to discuss today: precision, recall, and F1. Before we move to that, this is a structure of a confusion matrix. Now let me define the confusion matrix and get back to this image. A confusion matrix is a table that helps to evaluate the performance of a classification model. Like I said before, confusion matrix is one of the evaluation metrics for classification model, not for regression model. So what the confusion matrix does is it shows how many predictions were correct and incorrect for a class. So let's go back to the customer's example where I said age, sex. So things like age, weight, height, we won't be able to particularly use confusion matrix to visualize it. Because now we're dealing with a classification problem. So the best thing there is going to be the sex, that is between male and female. Most classification problems are always binary classification, that is one, zero, true, false, male, female, black, white, that kind of binary classification. But to note, we also have multi-class classification. You are going to probably encounter that moving on as you're advancing in machine learning. So um, back to the sex class we are trying to predict on. So if I have various section, maybe for consistent customers, I'm trying to predict the sex for non-consistent customers. I can use a confusion matrix to see which class, that is, if that class sex was correctly predicted or incorrectly predicted. So what it does is it compares the model's predicted labels with the actual labels. Now, my model, what I'm expecting from my model, maybe I'm expecting a male for consistent customer based on various features, variables that I predicted on, and then I get a female. That is already wrong. So now the confusion matrix is going to make it clearer to you where it is wrong and what amount of class went wrong and what amount of class was right. So we have the true positive, the true negative, false positive, false negative. The term confusion matrix, if you see the diagram, it can be quite confusing sometimes when you are trying to understand the table. Back to this table, let me explain it here. If my model predicted yes and the label I was expecting or my target variable that I was expecting was the actual one, then that is the true positive. Now, if my model predicted no, but the label that was to go out was actually true. Let me go back again. If my model predicted no, that is, based on this classification, based on these features, the actual label we're expecting is maybe a female and it predicted a male. That is already false negative. Now, if my model predicted yes for female and I was actually expecting a male, that is already a false positive. Same as if my model predicted no for male and also predicted no for male, that is already a true negative. I will get back. Are we confused?
Yes, so
the,
please.
con- the
Yes,
confusion.
oh yes, yes, Melody.
Let me let me let me see if I can still break it down more and more. So this is true positive now. True positive. You predicted positive and it was really positive. Correct decision. Correct detection. So, for example, in practical sense, after building the model, and that particular patient has, let's say we are doing disease classification, as malaria or does not have malaria. So the model predicts the patient has malaria disease and the patient actually has malaria disease. So the patient came to the hospital, is probably using a machine learning model. Patient knows, the patient has so much evidence with him or her that okay, I have malaria disease, and then she puts in probably her age, her weight, her symptoms, blood pressure, and the model predicts that the patient has disease. That is a true positive. That means both on the reality and the model side, it is true. True positive. Is that okay?
Yeah.
Okay. Now, true negative. The patient does not have the disease. The patient kept all the features, the blood group, the blood pressure, the age, the weight, and everything. The, put it to the machine learning model. The machine learning model predicted that, oh, this patient is not does not have mosquito disease or does not have malaria disease. Therefore, the patient is healthy, right? And the patient is actually what? Healthy. So that is a true negative.
Negative. Okay.
I'll still draft off more examples and I'll
So
send
just
to
a
you.
question. That's a true
Okay.
negative because the
Okay, what's your
original
question?
that's a true negative because the
Yes.
original prediction was that the patient has malaria, right?
No.
Wait,
The
yes.
original prediction from the model is that the patient does not have malaria and the patient actually does not have malaria. So we are looking at the
Because
patient has
that's
malaria.
okay.
The patient has malaria or does not have malaria. That is what we're looking at.
So if the
Classification
patient has, the first one is the true positive is that the patient has.
has, yes.
Okay.
And the model predicted that the patient actually has. The
Okay.
next one, the patient does not have, and the model predicted that the patient does not have.
So that's
So
true negative. Okay.
that's true negative. Now for false positive, it's also called type 1 error. It's the false positive and false negative that makes the confusion matrix seem confusing according to the name. So the patient actually has the disease. She puts in her, her details, blood group, blood pressure, age, that and that. Then the model predicted that the patient has the disease. That is already incorrect. That is, the model, after taking in all her values, that patient is very much healthy. What she's expecting is that she, she does not have the disease. That means the patient is healthy. She's expecting the model to tell her that, oh, I am healthy. But then the model tells her that she's not healthy. So now that's a contradiction, right? The reality side is that it is positive. The model side is what? Negative. Therefore, false positive. Is that clear? The model is raising a false alarm, literally, because the expected result is meant to be true. She's healthy. But then the model predicted that she's not healthy. So that is already false. But now it is a false positive because she's actually healthy. Are we clear with that? Do you need me to expand on that?
Is it possible that as we go forward, we will understand better so that we don't
Okay, take time here. Okay. So,
maybe as we continue learning, maybe we will
okay,
understand
yes,
better.
yes.
All right.
So, um, For the false negative now, I don't have it's called type 2 error. The patient has the disease, the model predicted the patient is healthy. So the negativity is that if we're looking at the binary classification, as malaria, does not have malaria. Does not have malaria is what? Is a positive response. As malaria is what? A negative response. So let's take it now. That has malaria. The patient actually has malaria. She puts in her value, she puts in everything to the model. The model predicts that she's healthy. She is already on the negative side. The model not predicted that she's healthy. The model is also wrong. It becomes a false negative because the model is missing a real case. Maybe the model is not predicting properly that, oh, she's blood group O, or the model has never tested on blood group O. So the model just assumes generally that the patient will be healthy because maybe her weight for healthy people, you'll be 55 kg, you'll be, 150 centimeter tall, and you'll be particular features that goes with it. So the model just generalizes and says, oh, that patient is healthy. It's missing something. It's not looking at something in the feature. It's not, the error is not right. What I mean the error is not right is that the error is too high. So it's just predicting that the model is healthy. Sorry, the patient is healthy. So we'll see this confusion matrix in an example. I'm using cargo. I don't know if we are very familiar with cargo. If we are, let's say hi. Okay. I would recommend using cargo for beginners or intermediates, even advanced. So cargo is an open source data science learning platform. Let me open the one I have here. So this was the regression analysis from the last class. I just uploaded the file on Kaggle. I saw we were using Jupyter Notebook. It can still run here, Jupyter Notebook files, Python files. So it is user
We can't
friendly.
we can't see your cargo
Okay,
screen.
you can see it. Okay, I'm coming. Let me share my window. Can you see it?
We can see your PowerPoint. Yes, it's up now.
You can see the cargo.
Yes.
Let me go to the home so you can see how it looks like. I recommend it. It's good. It's one of the things I started with. I think because of the network. Um, it's not reloading, so but you can create an account. It's free to create an account. So I uploaded the regression analysis you were working on before. So this is it. So back to the PowerPoint. I have an example that is explaining this confusion matrix. So this is for the example I'll explain later. Is on the Titanic data sets. So moving on, can we see my PowerPoint slides? So imagine you are catching a fish and you only want salmon or you only want kote. You caught 10 fish, 7 of them, they're actually salmon or kote, 3 of them are not. 7 of them are true positive, 3 of them are false positive. In precision, now this is a calculation aspect, but you would absolutely have nothing to do with the calculation. But let me just tell you the formula because we have libraries that can handle precision, recall reports for us. So the precision, you want to know how precise what the catch is, what we
We can't
actually
see.
call.
We
You
can't
can't
see
see
your
what?
news. We can't see your new screen.
Okay.
The PowerPoint. Maybe you should share the entire screen so that when you
I think I
switch.
should. Let me share the, let me share the entire screen. Okay. Sorry. I'm trying to quick share the entire screen. Probably network. Okay. Back. So I was talking about precision. Imagine you are catching fish, but you only want salmon or potato. Caught 10 fish, 7 of them are actually salmon or potato, and 3 of them are not. So precision, like I said, these evaluation metrics, if you can recall properly, they are rooted in statistics and calculations. So precision, the true positive divided by the true positive plus false positive. That is the formula. Now, I said you would absolutely most likely not need these calculations unless you are into statistics and the likes, because we have libraries for them that will give us reports based on it. So precision, like the name implies, how precise where it catches. So my precision, if I'm looking for 10 fish and I only want 10 salmon, so I'm trying to look at my precision is how precise did I actually catch those salmon? Like amongst my fish, was salmon the main thing I wanted? So high precision means I didn't catch different various fish. High precision is good. High precision of a model means that you are actually looking at the classes and you're picking specific values, to predict based on the prediction values. That is based on the prediction classes. Maybe I want to predict on age and sex. So we are looking at it that, okay, my precision is very high for that. Then for recall and F1 score, recall, you are now looking at if your model actually, like name implies, if it recalls on certain things, if it remembers certain specific features. So I recall means you can catch plenty salmon as possible. That means you are looking at those specific features and you are actually noting them. The model is noting them. The model is recognizing those specific features. That is, the model is recognizing that if I'm to predict that you're healthy, you must be this particular age, this particular size, this particular height. The model is looking at those things. Those are things like high recall. So now we have to balance between precision and recall. Remember, precision is precise that am I getting the 10 particular quote or salmon? While the recall is looking at I can get as much as many fish, but then I am getting quote and salmon most especially. So now I don't want to get too much fish, then I don't actually get my salmon or my quote. So we have to balance it. That is where the F1 score comes in. And the formula goes as thus: 2 times precision times recall over the precision and recall. This is also called the harmonic mean. It shows how good your model is balancing on precision and recall. Are we clear with that? Okay. So SK has something called classification reports. So I just put this in. We might see it going further. So the classification report, you need to understand it. You don't just see it when you're trying to evaluate the metrics. You need to understand how good your model is performing. So precision is important when you want few false alarms. That is something like does not have disease, has disease. So now you want to be precise on that does not have disease. So you have to put in some few information for that does not have disease. So the model will be able to recognize that I'm not only predicting on has disease, I'm also looking at does not have disease. I'm also looking at, oh, if the patient can also be healthy. So recall is when you don't want to miss anything important, like the disease detection. Remember when I said recall, you're looking at specific features. Yeah, you are taking as much kote or fish, but your model is training, looking at specific features to recognize. So that is what recall is. You don't want to miss anything important. You are noting this down about your patients, maybe this particular age. After giving the age, you notice the weight, the height. You are not just stagnant. Your model is not stagnant on specific set of values. Your model is exploring. That is what recall is about. So F1 score gives you the balance between both of them. Now, this is the evaluation metrics for classification models mainly. I'm not able to list classification models here, but we have logistic regression. That is what we are going to be using in the example code. And I know we might be wondering why is it called logistic regression. But yes, that's the name. This is not a regression model. Regression models now, the evaluation metrics, we have mean absolute error, mean squared error, root mean squared error. This is also rooted in statistics and calculations, but we don't need to focus on that. What we are doing is what's building models. We just need to import the libraries and understand our metrics. So the mean absolute error, we need to understand the absolute difference between the predicted and actual values. Remember, we are dealing with regression models, and regression models deal with things like continuous variables. When I'm saying continuous variables, if I say age, size, like height, we can get height of 14.5. That's not an actual height, sorry, but I'm just putting numbers. When I say continuous variables, they are numerical values, most likely. Classification deals with categorical values. Regression deals with mostly numerical values. Now, it's not only numerical values, you see, but continuous variables. So, in general, we want to see with the mean absolute error, as the name implies, is like taking, if I have 10 ages, 10 age in a particular age column, so the mean absolute error, it takes the mean of each error. That is the model. Maybe the model will predict on particular things, and then I apologize if it is getting too much mathematics, but I'll make it simple. The errors, it will take the mean, that is, it will add them. The errors from predicting the age, maybe it's predicted wrongly. So the errors, they are always in numbers between zeros and one. So it takes those values, adds them, and it divides them by the number of ages. That is what mean absolute error is. Now, we don't see this in the forefront when we're coding. We don't need to see it. So why do we need this mean absolute error? It is easy to interpret. It treats all error equally. So now, if we're doing a house prediction, a house price prediction, like I was explaining then, I know my examples are a lot, but please let's try and keep up with the examples. So I said you have a particular estate and this particular plot, you want to predict what's going to be the price based on the land size, the bathroom size, the materials used, how we build the houses and everything. So if my mean absolute error, if I predicted $10,000 for a particular plot, and sorry, if my model actually predicted $10,000 and the mean absolute error is $5,000, that means we're off $5,000 on average. That means the house is actually maybe in reality around $5,000. That is what it means. So lastly, we are going to the mean squared error. The mean squared error. So now those errors that I was talking about in the age, maybe the model predicted the ages, for every prediction, there is always an accuracy and an error, no matter what. Let me repeat that. For every prediction, there's always an accuracy and an error. You might be wondering that your model will predict properly. Does not mean does not have an error. If I'm working on a model to see this particular image, and when I see the image, it is true, it is the actual image. So what happens, what my model did now at the back is that it had high accuracy and low error. That is why it was able to predict that this image I've given it is actually the name. Let me say a picture of a window, and I actually take my model to predict a picture of a window in real life. So when it gives me 96% accuracy, that means my accuracy is high, my error is low. So this evaluation metrics for regression model, we are looking at the error. That is where mean squared error, mean absolute error, and root mean squared error goes. So why is mean squared error good? It penalizes larger errors. It highlights the models that make fewer big mistakes. So when it says it penalizes larger errors. So when I have in that particular age data set or that age column, and the error is high, if I'm looking at the mean squared error, if I'm using mean squared error, I'll be able to evaluate, because if you notice mean squared error and mean absolute error, mean squared error is always higher. So what the mean squared error does is it penalizes larger error. So when it squares them, squares them, squares them, squares them. So those ones that are high, by the time you square it and you turn it to the mean, the errors are balanced. They are like reduced. There's a balance. So another thing to note is that a lower mean absolute error, also a lower mean squared error, when you're comparing models, when you're selecting models from their results, it shows that one model is better than the other when you have lower values. If and only if your models are given the specific target variables and they are trained on specific values. So you are looking at that regression model. You are looking for a lower MAE. So now if I want to know the age of the females, let's go back to AliExpress example, the females that are very consistent, and I train on the weight, I train on the height, and then I add something, I add probably race, or I add, you know, let's put something abstract like eye color, yes. And so if I only trade on the weight and the height, although the eye color is really insignificant, let me look for something. Consistent customer. Okay, yes. The frequency of the person coming to AliExpress, the weight, the height. This is an example, so I'll say something behind the weight and the height. So because I added this frequency of the person visiting the website, if you check In real sense, if we are to check the mean absolute error with only the weight and the height, for checking for consistent customer, what is my target consistent customer? And I do weight, height, and the frequency of coming to the website or the frequency of visiting the website. The one with the frequency of coming to the website would have lower mean absolute error. Why? That frequency of coming to the website has more significance to my problem. I want to know how consistent female customers are. The weight and height might just really help me to know if they are females based on their size and everything. But the frequency of coming, it could be the frequency of coming to the website. That it could be like weekly. You can see 5, 4, 7. So that extra feature is going to give me a better advantage because it's going to have a lower mean absolute error and mean squared error. And some models, because they look at classes very well, they look at features, they select features very well, they can have lower mean absolute error and lower mean squared error compared to other models. So that is another thing we can look out for. So this is the end for the explanation of model selection and model evaluation. Going back to our objectives, I hope we understand why we evaluate models. We know what a coefficient matrix is, and if we don't, we'll still understand its practicing over time. We understand precision, recall, and effort score with the example of cote and salmon fish. We know what mean absolute error measure and mean squared error measure. So we should be able to practice on the real data sets using SQL. So let's move to the cargo editor. I have run all the codes already. Can we see my cargo editor? If
Please.
we
Yes, we
can,
can. But
okay. Are we
is
lost?
this what platform is this? Online
This is
or
called cargo. Cargo. Let me put the home. You can
is it
open
still
an
part of
account.
VS Code?
It's similar but it's simpler because it is an open source, right? Where you can, take competitions, you can take short courses, you can just code on your own, then you can create data sets, you can do a lot of things, see models. People are building
Okay.
models every day, so you
So
can just join them to
how
do
do we
that.
get on this?
How can you get it?
How do we get on this now? Like, is it just
Okay. If you click on Google now, just type cargo, sign up, or cargo. So you click on it, you sign up, you use your mail, right? You put in your necessary details. No much confidential details, just your mail, you sign up. Then you set your password. Then you come now to you can just type this or you can type cargo.com. Let me open cargo. So you see something like this. This is open for, so because I've created an account, if I was to, okay, sign in, okay, let me see. I'm not seeing any sign up because I've created, but you should be able to see sign up or sign in because if you say sign in, you can just sign up to the cargo. But yes, it's very versatile. You can take your time to practice on the platform. If you have any issue navigating the platform, you can reach out to to your handler, and I would discuss on how to do it. Okay. Back to the regression analysis. So if you open a particular folder or another person's code, some codes are open, so you can even see what to practice. You can click on beginners. There is beginner, intermediate, advanced. They'll teach you what to do. They can show you codes to use. You just you click edit, then you try and put in your own code. So initially, now that I've signed in and I have the platform, what I did was, if you have a particular file you've been working with, you can still use VS Code, you can use Jupyter Anaconda. I'm just suggesting this if you want to practice, if you want to, join a competition and you want to see how you are working. The competition is not complex, they are free competitions, they are ones that are, they pay you for competing. So this, I will import notebook. That is my Python file. So that is how I was able to get this regression analysis here. So when I click plus code, it drops. This is called a cell. If you're familiar with Anaconda, so this is very explanatory. So moving on, I hope we haven't forgotten what our former facilitator explained on this, and we are not having any struggle understanding anything in this regression analysis. Was the code given to you people to look at?
Mhm. Maybe others should speak. Oh. I tried and kept hanging, so I didn't get to the end. Ah, Fitz, well done, huh? Please speak up.
Does anybody want to speak? You can unmute your mic and speak if you have any issue regarding the former, so that you can tell the host what's the issue. Okay.
Well, for me, hello.
Yes.
Yes, for me, I was getting error messages at some point,
Okay.
So I already shared with the host, like you said, but
Okay.
yeah, I was giving some guidance at some point. I was getting stuck again at some point. I was watching YouTube videos. So overall, like I was telling her, I think that somehow I would meet up, but I couldn't get to the end of all of these things to really get to understand them again.
Okay, so time won't permit me to explain everything,
It's
but
fine.
it's very good that you watch YouTube videos, you the errors, and you're trying to understand it. That is another good thing about machine learning. You have to understand your errors, you have to debug properly. It can be a simple comma, it can be a simple bracket that is missing, and it can be very, large, different libraries you're trying to understand, very time consuming, very, voluminous data science as a whole. So you're going to take it section by section. And sometimes it will be frustrating you, but as long as you are breaking it down and you are resolving it, it will definitely come out right. You would advance. That is one way. Patience is needed in machine learning. Yes.
Thank
So, yes, you're welcome. So, yes, this is where I started from. From here, I can see she did linear regression for a particular data set. I can't really remember, but these are my libraries. Pandas. Pandas is used for data manipulation. NumPy is used for arithmetic, also data manipulation, but more of data calculation. That is it. Let me put it as that. So now this sklearn is a whole library, but it's very good for model development. We have the sklearn model selection. This is what we use to, split our data set into train and test. Then we have the SK linear model. This is for the logistic regression. If we've been paying attention, I said something like logistic regression. Where I said logistic regression is a classification model, not a regression model. I know the regression name at the back can be confusing. We can Google the model just to, know why it is named like that, but they will basically tell you it's a classification model. Then we have the sklearn dot metrics. When I said we have the precision, recall, F1 score, confusion matrix, and I said it's all about statistics and calculations that we don't need to see it. We already have a librarian doing it. This sklearn, it has a module called metrics. It calls that module to handle performance metrics of a model. That is simple. This classification report handles the precision, F1 score, recall in a tabular form given the values. So Cborn as an SNS. When you see something as, import a library as SN as something. It means it's called an alias. It's called aliasing method in calling a module or importing a module. And we've not heard it before, just so when we get out there, we can say something like, oh, I know what aliasing is. So this matplotlib.py plot, now that is also a library. This is matplotlib.py plot. It's calling the module or the section pyplot in the matplotlib library. The pyplot is used to plot graphs. It's used to visualize your data in graphical forms, because most graphical forms are always plot, plot, plot. So now I'm using Titanic data sets. So like the former facilitator used an open source for different data sets. Let me show you. Okay. So yes, now in this inbuilt data sets that she just called, it has Titanic. It will be similar to the same Titanic I'm using in case you want to do that. What I used was a link to the Titanic dataset. The Titanic dataset is also on this cargo platform. Now, if I go to the site and I click datasets, I can type Titanic. You see the Titanic dataset. You see tutorial on it. This is the dataset. You see different works on it. Can we see it? Different people's open work on it. So yes, they are open data sets here. We call them open source data sets. Sorry. Okay. Moving on to my model selection explanation. We are about rounding up. I think we started by 6:38. So it's 28:15. We should be rounding up. Thank you for your time and for your eager desire to also learn data science. Data science is interesting. It's a lot, but it's good and it's interesting. Okay, so now this is a link. This is GitHub. I got the data set from somewhere. So the data set is in CSV. .csv is a file format, comma separated value. Our Microsoft Excel can be in Excel formats, .csv formats. It opens files like that. That's what I'm trying to say. So CSV arranges it in column and rows form. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 columns, 12 features, 12 classes. If you see this survived, is 0101. If you see this embarked, is SC. That is, I think this was set and come back. That means those that embarked on the journey to the Titanic ship and those. So if you see this cabin now, I can't specifically remember, but I think it's the cabin number, the room doors, cabin 85, cabin 123. Then the fare is the price, the ticket fare. Then the ticket is the ticket number. So this is the age, this is the sex. So now you see survived, sex, embarked. They are going between two values. Survived is between 0 and 1. Sex is between male and female. Embarked is between S and C. Now, this is what I call continuous variables. This age, this, this numerical variable, P class. The P class is passenger class. There were three classes. This P class, I want to retract a statement I made. This P class is not necessarily, not particularly, not even a continuous variable, but a multi-class column, a multi-class feature. That is, this P class, remembering the feature of the data set, the P class is 1, 3, 2. Is 1, 2, 3. That means like passenger class, like first class, premium, lower class. That is what is explaining. So moving on, you explore your data. It's good to explore your data. So we can see that when I was talking about data balance, we can see that from passenger ID to age, sorry, to sex, it was the number of data, the number of volumes, the number of entries, 891 entries was 891. This data set has class imbalance because age has 714, 204, which is the highest imbalance, has 204. Sorry, cabin, 204, which has 204. I think those are the two. So now this is why data exploration is needed, and we use df.info to check the information about our data set. You call the method .info. When you call a method, put it in bracket, you put two brackets. Yes, that's what it is. So this dot is null dot sum, is asking for the sum of each column. Which one is missing values? Is null is like does not have data entry. So now the age does not have 177 data entries. Cabin does not have 687 data entries. Embarked does not have two data entries. Moving on, so you can fill those empty places. You can fill it. Ah, it will be a lot to start explaining. The dot fill NA method means fill not available. So those ones that are having empty classes, you can just use a mock, like a fake data. So your SK, your pandas, sorry, I said pandas for data manipulation. You can fill it up with the nearest value. There are different modes. The nearest value, the value that you can even specify, There are, I can't remember the particular modes, but for the age now, we are using median. Median is middle number. So it will probably check the row and to select the median among particular values of the age, the median age, and fill it up in those empty spaces where age column does not have. To fill it up, fill it up, fill it up. So we are dropping cabin, ticket, name, passenger ID. I'll tell you why we are dropping cabin, ticket, name, passenger ID. Passenger ID for one is just the identification number. That is the continuous 0 to 891. It's not really needed. It's just to give the number of entries you have. The name, different people with different names. So we are looking at specific features. The name would cause it's not it's not going to be it's not going to bring out the specific features for the model to predict because we are predicting on classification model here. So we can't be looking at names. People have different names. So the passenger ID, we are dropping it. The cabin has is missing a lot of values. So instead of filling it up with this fill NA and with this mode, like I said, we have different modes. So this is mode is set to default. Instead of doing that for cabin, filling 687 values, we just drop it. It's not needed. And because we probably don't need cabin is not our most significant class or most significant feature we are looking at, if you understand. So I said getting dummy data values. So now, in our sex, we have male and female, right? Male and female. So when I'm getting dummy values, this is a pandas manipulation, data manipulation method. You can further read on it. So this sex now is now turned to sex male. So in the sense that it's looking at the values. If it is a male, it will be true. If it is a female, it will be false. It is putting it now to true or false values. The embarked now we have C and S. So instead of defining with pandas and saying C is for this, S is for this, go and look at this, you can just use get dummies. So it's we pick one of the class between the binary class and it's to classify on that. So it's classifying on male. So the first at passenger ID 0 or the first one, we are expecting this sex to be a male. Let's go and check our first one. So it is a male. The next one is a female. That is why that place is false. So same as this embarked. When it is Q, I'm guessing this is Q, not C. This is Q and S. So it has divided it that, okay, we are only looking at this column is only for Q, this column is only for S. So now we are going to drop survived. I will tell you later on why we are dropping some particular columns. So we are going to train and test our data sets. We have dropped the features that are insignificant to what we are trying to classify, to what we are trying to predict. Let me run it. I need to start all over. Okay. Let me start from here. Now it should work. So yes, remember to refresh your model importation. Sometimes when you close your tab very well.
Please explain that again. I think I was having the same issues because I had started working with DF already, and then at some point started telling me, I of course hibernated, came back to work, started telling me DF name DF is not defined.
Name DF is not defined. So before you run your DF, you were sure to, assign your CSV value. So maybe this is the name of your CSV. So you assign it to the variable DF, right?
Mm-hmm. Definitely, yes.
So you can just do df.add. So when you do df.add,
I
you
had
should
even
get
done that. What do you think you were explaining? Sorry. Before I said, please
yes,
explain that again. You're talking about refreshing. What does that
yes.
do?
Okay, when I say refreshing, there are sometimes that if you've continuously gotten error, it happens on some systems. That's what I'm saying. Your model should also look at resources. So when you refresh, it's a way of telling the computer because the computer also it knows that you're working on maybe VS Code or you're working on something. So when you refresh and you start all over, you import the libraries again. So the IDE for your Python, the when I say IDE, this is also an IDE in Cargo. We have Jupyter Notebook as an IDE. In VS Code, we have Anaconda as an IDE to there. So
I'm
when
working
you
with
refresh,
digital.
it helps.
Okay.
Yes. But if that does not work, you should still check it again. So let me see this error. Okay, this is a warning. Oh, so because I already dropped it, let me do it again. This happens. So when you drop, right? When you drop a column, it has removed it from that data set. There are different methods for removing columns from data sets. I won't be able to, expand on that. But when you drop, if I run this column again, it will give me an error because it has dropped cabin, ticket, name, passenger ID. So if I run it again and I'm telling the cargo the pandas to drop the same columns. If I'm running it again, it's not going to see it because in that data set, when you drop, it's not making a copy. It is dropping, it is removing it in the data set. You can make a copy of your data set and you can drop. Or you can just, when you drop, you remove it in the data set. So that is gone. Then I have this. I get my dummy figures. So now if I'm dropping survived, so remember um, in my x are my features that I'm using to predict my y is my what target variable. I want to believe the former facilitator said something like that because it is a very common thing in machine learning introduction using x and y for your target variable, your features. So my x after I have removed my cabin, ticket, name, passenger ID. These are the remaining values on the data set. So now I want to predict who survived the Titanic. Who survived the Titanic? The model is actually based on the Titanic story. I don't know if you've read on it. The Titanic downfall, that ship falling down. So who survived it? So if I am predicting unsurvived, I am not going to put it in my features to predict. I have to remove that column. Thus, the need to put df.drop survived. So my y is my target, my prediction results. I am looking at survived. Who survived? One or zero. Zero is for did not survive, one is for survived. So now this is my data set splitting. So after I've dropped it, now I can split my data set. You must be able to clean your data sets before you start training. I've trained my data set by dropping the columns I don't want. I drop the columns that add too much of missing values. I drop the columns that are irrelevant to the surviving because the cabin number is not necessary, the ticket number is not necessary, the name of the survivors, somebody can have the same name, it's not necessary. The passenger ID is not necessary. It's not so necessary actually. So now I'm looking at the sex, the age, and the passenger class. I'm choosing those ones to look at it. So let me run this. The test size 0.2 means that my data set was split into test of 20% and
20,
I'm
yeah.
training on 80%. Are we familiar with that?
Yes.
Okay, that's good. So I'm using logistic regression. I'm going to call, this is calling the model logistic regression. My variable, this is just classification, CLF, I shortened it. So when you call the model to predict, what do? You fit on your data sets, you're predicting and your target value, the trained one, then you predict on your test value. Are we familiar with that? Should I go again? Okay, that's good. So, okay. So, like I said, it's all about statistics. So if you still want to see, play with your code, if you do widespread, it won't give you the values. What it will give you is different. I said it's always between zeros and one. So it will tell you, oh, if you are looking at the first one, zero, did not survive, second one did not survive, did not survive, did not survive, survived. That is it. So this was the reason why we came for this meeting, model evaluation. So this is a classification model. My model I'm using is logistic regression. We can experiment on other classification models. It's been a while. I can't really remember other classification models, but I really remember logistic regression. Okay, so this is my classification report and confusion metrics. So I want to evaluate my model. Okay, this is not really important, but what I did here was,
Sorry.
yes,
From what you've done, you have trained the model, right?
yes, I've trained the model in my
Can we go
thing.
back to that training?
Okay,
Bit?
okay. This is where the training happened.
So what
This
did
is
we
training.
look out for in this
Yeah?
training?
What'd you say, Ma?
What did we look out
Ma, what'd you
for
say?
in this training? Sorry, can you hear me?
In this training. Yes, I can
I
hear you,
mean,
Ma.
what did we look out? What did we look out for
Let me,
here?
okay. So when you declare your variables, this is a variable for the features to train, the features to test, the target variable to train, when you're training on target variable based on the data set and the testing. So now it's always good to print out your results, extreme. So now it will show you the particular features we are training on for extreme. That is the importance of what you're training.
Okay.
So we've divided it that we're training 80% of the data set and 20% randomly to test. This random state shows that it's testing randomly. So if you run it again, it can be different values. It's good. Randomly training your data helps your model to generalize and understand. So that is what we're looking for. Is that clear? You can also do it for Y tests, Y. Okay. So
Yeah.
don't take much time. So yeah, like I said, this particular line is not so needed. This is kind of quite specific. So when I showed you here that it was between zeros and one, so if you look at 0 to 1, half of um half of it to be 0.51. So what I did was if my predicted value is greater than zero point 0.5, I should choose it as the Y predicted class. And then I should do a confusion matrix on the Y test and the Y predicted. So the confusion matrix is based on this Y test. Let me show you Y tests. So this Y test, these are my values. Y test is going to be just one column that is unsurvived. Randomly choosing 20% of the data sets on the column to predict. Do we understand that? Are we
That's
confused?
our targets, right?
Yes, 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 our target mainly. So it's between 0 and 1. So I was just specifying that if our target is greater than zero point 0.5, then you put it to the that means the person you put it to the okay. So sorry about that. You put it to the widespread class, that is the variable. So that would be like the true value. Like, okay, the person survived if this is greater than zero point 0.5. That is literally one. Do we understand that? It's still basically one. This is not so needed. It's just another way of explaining. It's 0 and 1.
So
So
from
if this is what do you say?
so from what you did before, the widespread that showed us zeros and ones. So the ones
Yes.
tells us the number of persons that have survived.
Okay,
Is it?
so this white spread, yes, based on the number. While this white test is the data set, this is an array. Sometimes the prediction value, for now, for regression, the prediction values will not be 0 and 1. Do you know why it's 0 and 1 here? Because it's a classification problem.
Because of because of what?
It's a classification problem. It's a classification
Okay.
model. So it is either true or false, 0 or 1. That is how it
Okay.
is. Yes, very straightforward. So this is the table for the confusion matrix. This is how sklearn does matrix. So you import it. So I just imported it again to show that you call the library model. So now the confusion matrix is looking at the actual Y test and the actual Y predicted. The Y test there are like various target variables, and the widespread are the predicted results. Is that clear?
It's clear,
So
but I so predicted results. Can we not have a total number of what is predicted?
predicted results. Okay.
So in this 0101, does the zero have a does the zero have value? I don't know how to explain it. So, but that's what I was asking. If the ones indicate the number of persons that survived, and zero indicates not survived out
Yes,
of
yes,
the
yes.
okay. So from here, is it possible that we are able to know the number from 11111? How many?
Okay, so I just printed this result so that you can just see that is a classification model. You
Okay.
Most times they don't look at this is an array. You don't need to look at this place, right?
Okay.
What you can do is your Y prediction, you can now convert it back.
So if we're to explain this Y prediction, how would you explain it?
Okay, so this Y prediction now that I've done the results, it's my value is either 0 or 1. So now it is in the order. This should be up to the 891.
Mm-hmm.
Oh, sorry, how many? Okay, I think so 712. at the end of the day after removing the columns and the rows. So if I'm expecting 712 values,
Yeah.
0 is for not survived,
Yeah.
1 is for survived. So there are various ways to interpret it back. We can use the graphical form, we can use the confusion
Okay.
matrix, we
Okay.
can actually turn it back to, I don't say data set, to a table, but that is a little bit complex. Turning back to a table. That is why your prediction value, you just need your model to give you your prediction value. So now if you can now test it again. When I mean test it again, you can get a new data set and you now predict on it. So you can get maybe a particular row. Now you can call a particular row like this, and then you do y pred for it. It will give you 0 or 1. That should be the value. I'm so sorry I didn't put it here, and time is fast spent because I have to start typing down the codes. So the precision and recall effort score, that's what I wanted to really quickly show you. So for the zeros, it's the model was able to have a precision of eight. You can read it as 81% or 0.81, and the model was able to see 0.79. So that means the model is is more precise on not survived than survived. That's one. The model recalls 89% at 89% of like not survived based on the general data set. So they're able to pick more specific features of people that did not survive than people that survived. So now the F1 score is just the 2 times this one over the addition. So this is my confusion matrix. Then the actual prediction 98. This is true positive, true negative, false positive, false negative. Let us confirm. This is the same image there, so I'll just use this quickly. So, sorry, true positive, false negative, false positive, false negative. Recall true positive, that means you actually predicted, the model predicted the person did not survive, or the classes, based on the classes that did not survive and actually did not survive based on what you have. So this is true positive, true negative, false negative, false positive. So the actual people that survived, sorry, the actual people, this is 0. Look at this side. Actual 0, that means 0 not survive. The actual people that did not survive, and the model predicted that they did not survive, 98. The actual people now that survived, and the model predicted that they, okay, the model
Survived.
predicted that they survived. Yes, this is it. So now our positive value from this model is that they did not survive. Our negative value is they survived. So now the actual people that the model said, the actual people that survived, yeah, this is 1. The actual people that survived, and the model said they did not survive. They are 46 in number. The actual people that did not survive, and the model said they now survived, which is wrong. This is false and false. They are 12. So you see your false compared to your true values. So this is true positive, this is true negative, this is false positive. So now between the true positive. This is, remember I said this is your true positive side. You can see your true positive is higher than the false positive. Therefore, it's actually predicting very well on actual zero. That means it's actually predicting that, okay, specific people did not survive. That is why this for zero is higher. These values, they're higher. For your negative, for the people that actually did not survive, it's not predicting negatively. Like the negativity is not so much. That is why this one is smaller than this one. Like I said, our true for this whole classification model is this thing. Pardon, just give me a minute. Is not survived while one is survived. So yes, it actually predicts more on not survived than survived. Thus, the value of this not survived. So when you're comparing survived and not survived for the false side, this is this and this. You will see that not survived is lower and survived is higher. Let me go back again. It's predicted it's predicted not survived highly. Yeah? Like very true, like very correct to an extent. And why it's predicted survived to be very true is not so high, it's 23 compared to 98. Where it's predicted not survive falsely is 12. Where it's predicted survived falsely is high. So it's better on the model predicted better on the output not survived. So this is regression analysis. Since the last facilitator already taught on regression analysis, the reason why I redid it was because I wanted to show this mean absolute error. And now that we understand what it is all about, this is linear regression I used, and this was um, the mean absolute error and the mean squared error. And I'm predicting to get, I mean, okay, I'm predicting to get the fare, the bus fare the people took. Like, if I should train my model and I should put this particular person based on their sex, based on their age, based on their P class, I should be able to know what they actually paid to enter the Titanic boats. That is why my Y here is fair. That is my target variable. So now, this is the mean squared error. Recall now, we can't use confusion matrix for this. We are dealing with getting continuous variable because the fare this can be $5,000, it could be $2,000, it could be 1,000. The spend could be $75, it could be 1 cent. You know, there it's not more a classification thing. It's not more true or false. It's different values, continuous values. So I also use decision tree regressor. This is another regression model. Decision tree regression. This is another regression model. We have regression models um that predicts as trees. So it takes classes, brings out specific values. So it's like tree, you have this branch, where you have similar branches, you go together, where you have maybe your branch is brown, you cluster together, it's like leaves and branch. It's taking particular things, attaching it to each other. That is the name. So it's based on those branches, it makes the decision. Based on the accuracy and the error of those branches, it makes the decision. So now, when I used decision tree, I did not really change anything. I've split my data set here. I've set it that my target is fair. So these are my feature variables. Let me show you what is in X. I might have to run this. So yes, to avoid conflict in names, I used X here before. So if I should run X without rerunning my regression model, it will give me the X for the classification model. So that's what they call naming convention. Once you name a variable something, try not to use that particular name you used in that same code, or don't use something so abstract, something so unfamiliar to rename your code. It will cause problem. It can cause error in your code. So if you've used X somewhere, you now come down to use X again for another model, it will cause problem. What you can do is um that's data visualization. I think we can always check that one. What we can do is rename it. We can even rename it to X fair, Y fair. Okay. Oh, let me separate this. I've already gotten domains, control X. So let me run my my data set again. I hope it doesn't give any error. Okay, we're predicting fair on the mail and embarked queue. So I already dropped it before, so it's going to give me error. So I have to run df from the beginning again. Let's try that. So yes, this is one of the debuggings we do. Are we still available in the class? Are we understanding? Mm, sorry, let me get this just alone. I need to call my data sets. I need to instantiate the variable for data set and use it. Okay, so 8 more minutes. Let me explain the MAE and MSE error. Sorry. Yes, the error, the evaluation metrics, how it works on regression model. So the linear regression, this is where I got the MAE was 20 and the MSE was 932.5. Okay. Okay. So okay, that's just a warning. You can filter your warnings. Let's see. Shoot. Okay, sorry. Just sex and invert. Okay. Okay, so now um I have to get the dummy on sex and embarked first. That's dummy values. That's where I'll do the true, false. Let me confuse us. That was where I did this thing, where my model will look at the male, the title, the label male, and to where it sees male to make it true, where it sees female to make it false. So I redid it here, like I said. So now my X now. Okay, I wanted to see if I've already copied my X. Okay. So we are dropping fair. Y also. Okay. So yes. Um, so yes, now I can see X. Okay, I remember what I was doing. I was trying to avoid the name issue. So you can see my X is different from the one before because I didn't drop so much. I didn't drop passenger ID. So I've split my data here 80/20. That's the standard way. You can do 70/30. So that's test size will be zero point 0.3. You can take note of that. So this is my linear regression model where I defined all my models. So it's true and error that I have defined my model. So you have to be sure of your model name. So sorry, we have time is fast spent. So this should work back. Um, okay, so I have categorical data. So my survived, my I've deleted something that added survived. So my survived, which other categorical data? My SIBS SS, my sex female. I have to remove them. So don't let me waste time. What I'm trying to show is that when I did linear regression, I ran it before, I deleted a particular cell. I got the 20.9 MAE. So when I use decision regressor, my mean absolute error was reduced to 16.04. So this is the reading. So it means that the lower mean absolute error, that means the decision tree model. This is all about model selection. The decision tree regressor is better than the linear regressor for this Titanic data sets to predict on the target variable fair. So because most of our when they say non-linear is like non When you have a straight line, that is linear. Non-linear, it could be circular, it could be lines that are not yet meeting or lines that are meeting. So that non-linear relationship means something external can influence the results. So that is why we brought in things like the age. That's why we brought in things like the age, what else? The P class. We can bring in those type of continuous variables. So they help in the decision tree. They help you tell now. This is because decision trees are capable of capturing non-linear relationships and interactions between variables, which may exist in data sets. So, like I said now, the passengers class, the age. So this decision tree is like a tree branch now. Is looking at it, picking, looking deeply at things like that. Linear regression just is looking at the relationship that would actually correlate. The word is correlation, would actually correlate to give you the prediction of the fare. While the decision tree is looking at things that you might they seem so little that is not a standing out factor, but can also help to predict the fare rates. So the linear regression, okay, this is what I just explained. The mean square error of decision tree is higher than that of the linear regression. So that means the tree made smaller errors on average mean absolute error. So I would advise for linear regression, understand how mean absolute error and mean squared error actually work. Try it with different classes, with different prediction target variables, like change your target variable. Maybe it might not be fair today, it might just be you want to test on the P class, or you want to test on the age, you want to predict the age of those people. Like maybe this age range, age 22, you know, that is what you can see the mean absolute error. We can just take the time to read this message about the linear regression and the decision tree. So the tree made smaller errors. I will explain that. It also produced larger individual errors. So this happens because the decision tree can overfit the training data and make extreme prediction um, on some certain instance. So now you say decision tree captures complex patterns. The complex patterns are the non-linear relationships, while the linear regression is more stable. Can we see? This is model selection. These are model selection factors. It's more stable. It has lower, for a linear fit, it has lower error. But for the mean absolute error, you recall that the one for the decision tree is lower. So for the complex relationship, the error is lower. That is for like other features. You're looking at other from age to P class to maybe passenger ID to, things like that. You're adding various classes. That is where we use our decision tree. Our linear regression, we are looking for a linear relationship. We know that, okay, if we're using linear regression, we are trying to state that based on to predict the fare, we are maybe just emphasizing, we are telling the model to emphasize on the age and the P class. And the model will be able to see that, okay, the age has more linear relationship than P class. That is how it falls in line. Thank you very much. That is the end. It was a good one, and I appreciate you for listening. I appreciate your attention. If you have any questions, contribution, you should please reach out to your facilitator through me, and I will look up resources to, explain the mean absolute error, um, the confusion matrix. I did everything just on short notice, and I'm sorry that I couldn't get visualization of pictorial values to explain very well.